Hi, today we are going to learn how to solve a problem with identifying objects in an image, and based on the identification, we can run our custom logics. As you can imagine, this topic was very difficult to solve in the past, and even in many places, manual control were taking place. Just imagine when the number of images grows and makes it impossible to be processed by a human work. But here is what makes this video special. It is not just a toy demo, it is a real scalable system that could handle lots of images. And it costs much less than it did before. At the end of this video, you will learn how to create a scalable, cost-effective system that can be automated with AI to detect objects from images. Alright, let's build this thing. And trust me, it is much easier than you think. This is what we are going to build today. We have a storage account which consists of two containers, which is called uploads and animal detected. Also, we have an Azure function with a blob trigger. Whenever a user or from the application, it doesn't matter, uploads an image to the uploads container, then our Azure function will be triggered. And then Azure function will send the data to OpenAI to process the image if there are any animals in the picture or not. And if yes, then Azure function, based on the decision of our AI, sends or copy the data with also some extra metadata to the animal detected container in the storage account. This is what we are going to do. Now, before we start the coding, I would like to talk about why this architecture is so powerful and where you can actually use this in the real world. First, let's talk about the scalability. This is a fully serverless architecture. What does that mean? It scales to 0 when no one is using it and you pay nothing. The Azure function literally shuts down. But the moment someone uploads an image, it spins up in milliseconds and starts processing. Also, when you have a high load, Azure functions scales up by the Azure and they can process lots of incoming requests for you. Each function instance can process images in parallel. So if you need 100 images, Azure might spin up 10, 20, or even 50 function instances simultaneously to process them. And you only pay for the compute time you actually use. Also, we can have global distribution. Because we are using Azure Blob Storage, your images can be replicated across multiple regions globally. Someone in Tokyo uploads an image, someone in New York uploads an image. Both are processed with low latency. This solution also is very cost effective. Here is the beautiful part. You only pay for what you use. No servers sitting idle around. No paying for capacity that you really don't use. You process 10 images in a day, then you cost only some pennies. Or you process 10,000, still incredibly cost effective. Now let's talk about real world use cases of this solution. For example, in wildlife conservation. This is huge for conservations. Researchers deploy camera traps in forests that takes thousands of photos in a day. Imagine having to manually go through, for example, 50,000 images to find, for example, 500 that actually contains animal. This system does it automatically for them. For example, security cameras recorded 24 hours a day, but most of the footages is empty parking lots. This system can filter to only show recording where animals or people appear based on the need. One of my clients uses this to only alert when a person appears, ignoring the animals or vehicles. For example, e-commerce and marketplaces. Imagine you are running an online marketplace like eBay. Users upload millions of product photos. This can automatically categorize them, flag inappropriate content, and even suggest tags, completely automated. This solution also can be used in social media and content moderation. For example, users are uploading billions of images in the social medias, and this architecture can scale up and automatically do the moderation like copyright detection and so on. Another example can be manufacturing quality control. Factories need to inspect product of defects. Traditional computer vision required months of training custom models. With ChatGPT Vision, you can describe what a defect looks like in a plain English, and it can detect it for you. And here is what I love about this. We are building one system today, but you can adapt this architecture to literally hundreds of different applications. This pattern is the same. Upload something, AI process it, take action based on the result. Now let's dive into some coding and implement a demo. I am in PowerShell now, and I just logged into Azure. You can log into Azure with this command, AZ login from here. Because I'm already logged in, so I will start now by creating a resource group here, which is called RG Then I will start by creating an Azure storage account. I would like to now create two containers on the storage account. One of them is called upload, and the other one called animal detected container. Then the next step is to create our OpenAI resource. In the same resource group, and just click. If you got this error message, you can try this command to register the cognitive services. And then we can try again to register our OpenAI service. The resource is created, and let's go to Azure portal and see what we have there. Here in the portal, we go to resource group. In our created resource group, we have a storage account and also our OpenAI service. So if we go to a storage account, in the container section, we have our two containers that we just created. From the security and networking, under access key, I will copy the connection string and save it in the notepad, because later we are going to need this connection string in our Azure function project. And now let's deploy our model. I go to OpenAI service. Here we need to click on Explore Foundry portal. And we need to create a new deployment. Here I will go with GPT 4.0 and just confirm it. Now we need to go to deployment menu, and from here we need the key, and I will just copy it somewhere, and also we need the URL endpoint, this one, to be able to add them to our Azure function project. I am now in Visual Studio 2026, and we need to add Azure AI OpenAI NuGet package to our project. Then we go to our local settings file. Here I will paste the Azure storage connection string and also the key for our OpenAI, and also we need the URL endpoint, which I also paste here. In our program class, we register blob storage client to dependency injection, And also we register Azure OpenAI client to the dependency injection. By the way, I will add a link to this source code in the description section. For this demo, I have 3 sample images that I'm going to test, and they are in the images folder, so they are inside the projects, and I will also push them with the code so you can give it a try later if you want to. And now let's see what is happening in our function class. I will zoom a little bit. So here in this class, we inject blob service client, Azure OpenAI client, and also the name of our model, which was ChatGPT 4o. And here we have an Azure function, which is the blob trigger. And if an image goes to this container, uploads, this function gets triggered, and we can see after that what is going on. First of all, here in the first section of the code, we convert the image to base 64 string, and then here in this part we create a message for the vision analysis. We create a text for the model that you are, for example, an expert at identifying animal in the image. So then AI knows exactly what to do, and he will respond us with a model which has a Boolean value, has animal, and also it gives us a list of animal. It depends what he found on the picture. And also we have a value which is called confidence. So how confident the model is to basically detect the animal in the image. Here we ask the question, does this image contains any animals? If yes, list all the animals you can identify. And also we upload the file, the uploaded image in the container to AI for the further analytics. Then here we call the OpenAI, and then we parse the result. If we see this function, it checks the AI response and returns us the appropriate response. I have here a class which is called animal detected result. So as I described it a little bit before, it has a Boolean, has animal, and a list of detected animals, and also how confident the AI is about the detection. So here, if we find any animals in the picture, then this code basically tries to make a copy of the image and upload it to the animals detected container, as we see here. And also here in this part of the code, we add some extra metadata to the image, what animals were found in the image and how confident AI was for the detection, and what was the date of this process, as I am going to show you later on in the blob storage how this works. So with that, we are going to now run the project and test the solution. I'm not going to deploy this project to Azure to win some time. And if you want later, you can do it by your own, and you should get the same result, of course. I divided the screen to 2 parts. In the right side, we see Azure portal. We are in the uploads container, and also left side is the Visual Studio. So we can check exactly what is going on in this way. I run the project, and then I try to upload the images. This is the images that we have also in the project. So I'm going to upload this file. Let me bring it here so we can see it exactly. There is a cat in the picture. So let's see if AI can detect this. Okay, I click on the upload and upload the image. Our Azure function should react now. And exactly, we are going to see the logs. Here now it is telling that processing blob. So now cat image is processed by AI. And as we can see in the AI response, we got our object has animal property is true. The animals detected is cat and the confidence level is high here, as we can see. And also the animal is copied to the animals detected container. So let's try now another image which doesn't have an animal in this one. I'm going to now upload it. So again, the image is under the process. And here we got the response back from the AI. So there is no animals in the picture and the confidence is also high. So AI is sure that there is no animal in the picture. Let's again try another picture, which is these horses, a lady with these two horses. I will again click upload. AI went for analyzing. We got the response back that has animal is true. The animals detected is horse and the confidence level is high. And we can now go to our other container to see what happened. We were able to copy two pictures from the tree which they had animals in. And for sure, we see here that we have our two pictures, cats and horses. So I click on them, one of them, for example, to show you the extra metadata that we just added by the code. So here is our metadata section. We have here animals, which is cat, confidence high, and the detected at property, which is the current date. So based on that, you can add the metadata that makes sense for your project as you wish. It was pretty cool, right? And this is just the beginning. This same architecture can be adapted for facial recognition, medical imaging, quality control in manufacturing, and much more. Alright, that's it for today. Thank you for watching, and I will see you in the next video. Until then, keep building amazing things. Ciao.